Hey guys, this is Miss Billingsley. Today we are going to be learning about key features of quadratics. So, on your note page that you picked up on Friday, go ahead and follow along with me as we fill in these notes. So these are the 6.K3.1 notes over key features of quadratics. Whoops, let's see if I can spell. Okie doke. So go ahead and add this title to the top of your page. The first key feature we're going to be talking about is maximum and minimum. We do already know about these from absolute value. They are similar with quadratics. A minimum has a very lowest point on the graph, like our first example. Our first example has a minimum at, what's that coordinate point? 0, -4. Awesome job. Okay, so this is either the highest or lowest point on the graph. Our second example, does that have a maximum or a minimum? This one has a maximum. Great job. And where is it located? Its coordinates are at 1, 2. A maximum at 1, 2. So similar to absolute value, minimum and maximum. Okay, next we're going to talk about zeros or roots or x-intercepts or solutions. So we've probably heard of these as intercepts before, but all of these names mean the same thing. This is on our graph where, at the location where y equals 0. So on your paper it says f of x equals 0. Remember that f of x is a fancy way to say y. And this is where the parabola crosses the x-axis. Okay. Sometimes with quadratics, our parabola will cross the x-axis 2 times. It is also possible for it to never cross it, as well as cross it 1 time or have that vertex on the x-axis. So with our first example, we actually have 2 zeros or 2 roots on our graph. The first root, I'm going to start with the one on the left. It is, let's use the coordinate to state its location. So that coordinate is at -2, 0. Remember, we want to make sure that our y value is 0 on these because that is where they actually are 0. So these x values are what we're really interested in. And the second one is at +2, 0. So go ahead and label those on your graph. Okay, let's look at our second one. Our second one opens down, but it does still have 2 zeros on our graph. So I'm going to go ahead and label those and then locate them using their coordinates. The first one is at 0, 0. It actually crosses at the origin. And the second one is at 2, 0. Crosses the x-axis at 2. Okie doke. Remember, these do have many names: zeros, roots, x-intercepts, as well as solutions. If we were to solve algebraically, we would get the solutions to the quadratic. Okay, let's take a look at another familiar word, domain. This is the set of the function's x values. Okay, so I'm going to underline x values to remind me how to read my graph. I'm going to be looking along the x-axis for these from left to right. This should be a little bit familiar. Okay, so if we're looking from left to right on this graph, remember that quadratics or parabolas are continuous. So if I'm looking at the left side of the graph, for example, number 1, that left leg goes up to infinity. as well as going slightly to the left forever. So its interval, so we're going to use interval notation. Its interval actually starts at negative infinity and then swoops around and continues all the way to positive infinity. So we're reading the graph left to right, so smallest to greatest numbers on our x-axis, left to right. Okay, let's take a look at our second example. Again, reading from left to right, I'm going to look at both ends of the parabola, starting with the left side. My smallest number, it is also continuous. So using my interval notation, this parabola also starts at negative infinity, swoops around, and goes all the way to positive infinity. Okay, let's take a look at range. This is like the sister of domain. For range, we read the y values. So this time we're going to be looking at our y-axis. Again, from least to greatest. So this time from bottom to top. Okay, so I'm looking at my smallest y value. I'm going to zoom in here. Okay, so it actually starts down here at -4, and with interval notation, if we have a hard start, we use our hard bracket. So I'm going to use my hard bracket and start at -4, and then look up on the parabola. Both of these legs continue up to infinity forever. So from -4 to infinity. Make sure you have the right brackets there. Okay, taking a look at our second example, kind of similar here, but a little bit different because, the legs are pointed down this time, which means that the starting place, if we're looking from least to greatest, it's actually going to start at negative infinity. And then we're going up, up, up on our y-axis and seeing that it stops right here at +2. It's a hard stop there. I can't go any further, so I'm going to use my hard bracket. Okay, so from negative infinity all the way up to +2 for the range. Okie doke. Let's get into some more not so familiar words, starting with increasing. Okay, so increasing is another interval. We're looking, I think we've seen this before. We're looking for where the graph is growing from left to right. So we're looking for the interval that x gets larger as f of x, or y gets larger. So I'm looking for which x values get bigger as I go from left to right. So let's make a note here that the interval we're looking at is going to be the x values. Okay, so again, reading from left to right, we're looking on our x-axis. And looking where the graph is growing. So at what intervals or which parts of the graph would I be climbing uphill? So if that makes more sense to you, you can add that note. The uphill portion. So from here at the vertex, all the way to the right side. Okay, if I'm looking on the right of my vertex, all of that is going uphill. So if I was climbing this graph from the vertex at the x value 0, okay, so I'm going to hard start at 0. And then looking to infinity, we would climb all the way up to infinity. So my increasing interval for this one is from 0 to infinity. Okay, looking at our second example. Okay, we're looking for which portions are climbing uphill. Okay, so from all the way back here at negative infinity, let's take a look at the x-axis. I would climb this graph from negative infinity all the way up to the vertex. And let me actually correct myself on the previous one. We consider the vertex kind of neutral as far as increasing and decreasing. So on that previous example, let's switch that to a soft bracket, since 0, or our vertex, is going to be neutral. Okay, so we don't have a hard start there. My bad. So this one is increasing from negative infinity. Remember, we're looking at the x values only. All the way to positive 1 is where it stops increasing. So negative infinity to positive 1. Okay, very similar notion for decreasing. Still looking at our x values. The interval as x gets larger as the y gets smaller. So we're looking for those downhill intervals. If I was climbing the graph, which parts would I be going downhill on? So it's kind of the opposite of increasing. If your graph has an increasing interval or your parabola has an increasing interval, the other parts of it are going to be decreasing. So if we're looking at our previous example, the other half of the parabola is decreasing. All along here, I would be going downhill. So we're again looking from left to right. But this time, my left interval, or that left-hand side of my parabola, is the decreasing portion. So this time I'm starting back at negative infinity and stopping decreasing at 0. Okay, remember the 0 is neutral. Okay, similar for the other example, it's going to be the other half. So starting at our vertex and going downhill on the right-hand side. So I would be decreasing from the vertex all the way to positive infinity for our x values. Okay, so the interval would be from 1 to positive infinity. Okay. Now, those are a little bit new and tricky, so if you have questions over those, be sure to join our Hangout and get those answered. Okay, what's a little bit more tricky is positive and negative. These are some that are a little bit more difficult, but what we need to think about is above and below. So for positive, I'm going to relabel it as above. And for negative, I'm going to consider that below. Okay, for the positive intervals, sometimes there's more than one, sometimes there's only one. There could even be none if the parabola is entirely below. But what we're looking at above and below is the x-axis. Is it above the x-axis or is it below the x-axis? So these are the intervals where y is greater than 0. So we're taking a look at our y-axis and splitting it with positive and negatives. So these two intervals for our first example, those two portions there are both above the x-axis. See how all along those, the y value is greater than 1. Not greater than or equal to, but strictly greater than. So for this one, I'm actually going to have two intervals. So I'm going to write my first one starting with the left-hand side. So again, least to greatest. My leftmost interval starts at negative infinity. Again, we're using x values. To negative 2 is where that one stops. And if we want to conjoin intervals, we use this U, which means union. So we're going to union the two intervals together since they're both positive. So negative infinity to negative 2 and in union with 2. So my second interval starts at x equals 2 and goes all the way up to infinity. So notice for none of these, I used a hard bracket because those are not included. 0 is neutral. Okay, let's try the second one. Notice on the second one, there's only one portion that's above the x-axis or positive. So this one is only going to have one interval, and that interval goes from 0 to 2. Okay, we're not looking for where it switches or has a vertex. What we want to look for is the single interval where it is above the x-axis. So this just has the 1. It's tempting to combine the positive negative with the increasing decreasing, but we're only looking above and below for these. Okay, last one is negative intervals, which are going to be below the x-axis. Okay, so these are all the intervals where y is less than 0. Not equal to, but strictly less than. So it is the opposite portion of the parabola if we are comparing it to our previous positive examples. So on this one, the bottom portion of my parabola from -2 to +2 is below the x-axis, or negative. Okay, so when we combine all of these intervals, we should have the entire parabola. So when I combine, let me see if I can highlight. If I combine this one, whoops, I meant to do a star. This one with this one and this one, I should get my entire domain. If we're missing any chunks, then we've left something out. Okay, so all of these together should cover my entire parabola, and in this case they do. So we are good to go there. Okay, looking at our last example, the two legs are below the x-axis. So these intervals are going to actually have 2. So we'll need to union them together. The first one, if we're reading from left to right on the x-axis, actually starts at -infinity and stops being negative at 0. And then we're going to union that with the other piece that starts at 2 on the x-axis and then continues until infinity. So this interval goes from -infinity to 0 and from 2 to infinity. Let's double check that we've covered the entire domain. This would fall right in between these two intervals, so we are good to go there. Okay. I'm going to zoom out so you can fill in any blanks. If you need to pause the video, you can. We'll also be posting the PDF for the key in case you have any blanks after you're finished. But if you have any questions about anything I have talked about, write those down so you can ask those during the Q&A sessions. Alrighty. Thanks for watching.